Now, before we finish up this instance particle example, there's one major thing we haven't added to the sim, and that is collisions. So the collisions work a little bit differently than they do in Bullet. So let's go back to our scene, and next to the unpacked version of our original RBD sim, let's drop in a collision source SOP. And if we connect our unpacked geometry to that collision source, this is going to make sure that we have good input for our collisions in the particle sim. The first output is going to be the geometry with trailed velocities. I'll call this collide geom. And the second output is going to be an SDF version of our geometry. So I'll call that collide volume. On the collision source SOP, I'm going to leave most of this at their default values. However, on the volume, it looks like the default voxel size of 0.1 is a bit low resolution. So I'm going to refine that by lowering the voxel size a bit. It looks like 0.5 should give us some pretty decent collisions. You don't want to go too high res with this, or it might be slow to compute and slower in the simulation. Now to add the collisions to the DOPNet, let's dive inside, and next to the ground plane, we'll create a static object, and we'll point that SOP path to ... to get to weak 6 debris tests, where the DOPNet lives, and we'll point that to collide geom. Make sure you turn on deforming geometry because this is an animated input, and I'll start by turning the bounce down to 0.05, just so it's not very bouncy for our initial sims. And then if you go to the collisions tab, you can choose between either volume collisions or surface collisions. I typically start with volume collisions, and if that doesn't seem like it's working well, then I'll switch over to surface collisions, although volume does tend to be faster. And when I use volume collisions, I pretty much always set the mode to volume sample, and then point that to a proxy volume in SOPs, so that collision source SOP already set up a nice collision volume for us, so we can point that proxy volume to ... / collide volume. Now the solver will interpolate your collider on its substeps, but if you want to use the exact substeps from SOPs, you can turn on this re-evaluate SOPs to interpolate geometry option. But generally I don't bother with that unless I can visually see an issue with it interpolating instead of reading that explicitly. It is slower to use that option. But now that we have our static object set up, we can merge that with the ground plane. And now we're all set to run our sim with collisions. Now if we play back this sim, it looks like things are colliding with our primary RBD sim, but we're having some really strange results and some really weird jittering collisions. So this is one of those problematic cases where it may just be easier to use surface collisions instead of volumes. So to switch that collision type, it's as simple as diving into our DOPNet, going to our static object, and on the collisions tab, we'll switch that collision detection to surface collisions instead. Now our new simulation with those surface collisions is looking much better. We're not seeing those weird jittering results that we were in the last version, and this is looking pretty good. Now one artistic comment I would make on this is that it's very obvious which layer is the primary RBD sim and which layer is the extra particles. And one of the things that makes for a really nice destruction shot is when there's not an obvious distinction between those layers. So if we wanted to improve this example, we could add extra bits of fracture to our original RBD sim, so there are some more small and mid-sized pieces in there, or we could add the extra RBD debris as another layer so that it kind of fills in the size gap between our primary RBD and these debris particulates. So there are multiple ways to approach this, but the important thing is that you kind of fill out those size distributions so you don't have such drastic differences between your layers. Now, similar to the RBD debris example, For this particle example, you would cache out those points right after the simulation. So I'll add a null that says cache particles here, but I'm not going to bother since this is a fairly lightweight demo. And then you could just render these instanced particles directly, and this is another case, like with the RBDs, where you want to make sure that you're using velocity blur because interpolated blur will not work with changing topology. However, we currently don't have any velocity on our instanced pieces, so if we go back to our copy stamp and then go to the attribute tab, you can turn on use template point attributes. And this is giving us a lot of stuff that we really don't need for render, so you can replace the set portion of these 2-point attributes and get rid of all of that stuff and just specify W. We already have V specified under the attributes to be added. And now if you middle mouse on that null, you can see we have velocity and angular velocity, and these debris pieces are good to render.